That's okay, Lauren. All right. You know that South African crowd in my class, right? Wonderful. Pretoria. God bless Pretoria. Excellent place. Okay. So, take 2. Lauren, try to control yourself. Excellent. So, this is, we did such a good job though, didn't we, in the beginning of that video? Wasn't that wonderful? Now this is period 2, atomic radius, correct? As we go down the periodic table, down the vertical columns, what happens to the size of the atom? It increases, right? So let me ask you a question. As I go down the periodic table and the principal quantum number increases from 1 to 7, what happens to the atomic radius? It increases or decreases? It increases. So the atomic radius is getting larger as I go down the periodic table. This is simply period 2. And this is a little bit more counterintuitive relative to what happens in the periodic table relative to atomic radius. What's the principal quantum number involved in each of these elements? 2. Where does each successive electron go from left to right? Where am I putting each successive electron going from left to right? Going from lithium to neon, where am I putting the increase in electrons? Energy level 2, right? Right? Energy level 2, right? Okay, excellent. Now, but what's also increasing as I increase the number of electrons, what else is increasing? The number of protons. Is there a charge to the number of protons? What's the charge of a proton?
Positive.
Positive, excellent. What's the charge of an electron? Negative. Electrons are small or large? Small. Protons are small or large relative to electrons? Large. Very much larger. Okay, good. So is there an attraction between the protons and the electrons?
Yes.
Are there? Yes? Okay. Now, the Bohr model is very useful here, even though the Bohr model is incomplete, Enzo. Okay? But here, the Bohr model, the Danish guy, it works quite well. It works well. Yes? All right.
Because we can see how electrons move up and down.
True.
It's easier to visualize.
It's easier to visualize. I like that. That's true. That's true. Now, see, in the Bohr model, you're literally, and it's not a terrible model. I mean, it's not a bad model. It's just an incomplete model. But in this case, the model works. And that is, outdated is a good word, I guess. So, as like your teacher is slowly becoming outdated, yes? The number of grandchildren and my outdatedness is proportional, yes? Okay? So, all these electrons are being put at the same distance. Think of it as a ring, right? Think of it as a ring here. Well, what's happening to the attraction between the nucleus and that ring? Is it increasing or decreasing as I go from left to right? It's increasing. Why are the electrons in the ring being attracted to a greater degree as I go left or right?
Because there's more protons.
Because there's more protons. What do you call that increase in protons? What do you call that? What do you call the charge in the nucleus? Nuclear charge. Gave it away, yes? So as the nuclear charge increases in a period, what happens to the attraction of the electrons as you move across the periodic table from left to right? It increases. So what's happening to the size of that ring? Is it collapsing on the nucleus and becoming more attracted? And it's getting so close and being ripped inwards so that it's almost imploding. Not quite imploding. You see that? So the electrons are being in that same ring are being drawn into the center of the atom. Does that make sense? So what's happening? What's happening to the radius, the atomic she likes it when I act completely mad. What's happening to the atomic radius as you go from left to right across a period? Is it increasing or is it decreasing?
It's actually decreasing.
It's actually decreasing, and that's correct. So the radius, as you go this way, is decreasing. It's decreasing radii as you go across the periodic table. Yes? Yes?
And also why more to the right of the periodic table, the electrons are harder to rip off.
Correct. I like that. He said, is that also why, as you go across the periodic table from left to right, the electrons are harder and harder to remove? And that's correct. There's a connection between the trend in increase of ionization energies as you go across the periodic table from left to right and the atomic radius. It's true. Now, let's do one more thing, okay? I think I have room. I may put it, I'm going to put the camera up a little bit, okay? All right, I think that's perfect. So what about the ionic radius? Now, we're going to say that these elements here which elements are going to give up an electron? What elements are going to give up an electron? Yes. Lithium, beryllium, boron, and we'll say carbon does. We'll say carbon gives up. We'll say today carbon is going to be +4, okay? So these atoms are going to give up an electron. So what's going to be the new valence shell of those atoms? Lauren's doing it again. No. Yeah, exactly. 1, right? So if lithium gives up its 1 electron that it has in the second shell, then what's its new outer shell going to be? 1, yeah. So they're all going to be 1. Right? They're going to be 1. Let's make it a little bigger so you can see it. Okay? What's going to be the shell of these? We'll put these in red. No, put these in green. These are going to do what? They're going to do what? They're going to take the electrons. So what's their valence shell going to be after they react? Yes. 2. Excellent. So are they going to be bigger or smaller than the positive ions? These are all positive. +1, +2, +3, +4.
Bigger.
Well, they're going to be bigger. Okay?
The ones to the left are going to become smaller, and the ones to the right are going to become bigger.
Exactly. So these will decrease in radii, and so will these. Can you see that? Can you see that on the film? Can you see that?
That's why when you look at a water molecule, you see H2O, O is big, and the 2 H's are smaller, right?
Exactly.
So,
Excellent.
So both of them will decrease in radii? Is that what you're saying?
These are decreasing in radii, but these are decreasing in radii.
What? They're both decreasing in radii.
They both have the same increase of charge, right? This is going to be 3, 4, 5, 6, 7, 8, 9. So isn't 3, 4, 5, 6 going to become smaller? Isn't it?
Yeah.
Because of nuclear charge, right? And isn't 7, 8, 9 going to become smaller, but still larger?
Yes.
So if you put these right here, see if I have room. And then we're done. Yes, we have room. I want you to put in decreasing atomic radius, ionic radius, ionic radius. What's the largest ion going to be in the second family? What's going to be the largest ion in the second family? Think carefully.
The one with the nitrogen?
Nitrogen, excellent. Yes. Isn't nitrogen going to be the biggest one? Because first of all, these are valence shell 2, these are valence shell 1. So these are larger, right?
Yeah.
But as this is going to decrease the radius because you're increasing the nuclear charge, right?
Yeah.
So it's going to be nitrogen, then what? Fluorine, right? Then, no, sorry, nitrogen, oxygen, sorry. Nitrogen, oxygen, fluorine.
Nice.
Yeah.
Then what's going to be the next? What's going to be next? Lithium, very good. Lithium, then what? Beryllium, boron, carbon will be the smallest. Carbon is very small. It's true. Why isn't neon included here?
Because neon doesn't react with
Yeah, blah. That's right. Neon doesn't form an ion. Right? Right? You get it, Ahmed?
Yeah.
The audience wants to know where you're from. I keep calling you out as Ahmed. So where are you from? What country?
Egypt.
Where?
Egypt.
Ahmed's from Egypt. He's very funny today. Are you like an Egyptian comedian, or do you like to stand up, or
No.
no? Okay. Okay, excellent, excellent. I don't think I've ever known an Egyptian stand up.
Me neither.
An Egyptian on the other side of the room said, "Me neither." Okay. All right. Okay. So, all right. We're done? So this was atomic and ionic radius. You get it? Yes? So, what did we look at? We looked at the atomic radius as we go down a group. We looked at atomic radius as I go from left to right. And we looked at ion radius as I go from left to right. Yes? We're off.